broadcast, and I saw that there was a question concerning the talk that I gave about why the hell do I want to have 99% of compatibility or something with the old stuff when it is actually clear that whatever doc is doing, it is not affecting the code. So if somebody has written a package using doc for documentation, I mean, the code will be still fine. But yes, I mean, the code is still fine that you get out with docstrip, say. But if I change doc and it doesn't work any longer, you don't have the same documentation. Now, there are two possibilities there. One is you process the documentation of all documents with a different package, namely the old one. Then you have the problem of having several packages, and this is part of the talk that I'm giving now. Alternative is you provide decent compatibility so that the old documentation still works. This is the thing that I'm trying to do. Or the third one is you ask all the package authors to update their documentation so that it works with the new version, which is sometimes the right choice, but I don't think it is here. If we have actually a coverage of nearly 80% of 5,000 packages or something, no, actually some of them are font packages, so let's say 2,000 packages, then that's quite a lot, and just asking them because I finally got around changing my code is not necessarily the right thing. Okay, so that would be my answer why I want to have this backward compatibility, because it's just sort of on the core of what is currently documented in the LaTeX world. So this time, and this is the topic of this talk, compatibility. Let's see if I get this in the right size. So I started off and then noticing that I'm talking about the wrong thing. If we look at the typesetting stuff, then we have these different time spans, and I want to concentrate on the last 4 decades, which are essentially the 4 decades where LaTeX was being introduced up till now. LaTeX 2, which is not many people will know that came about at 83. LaTeX 209 with this funny numbering is the one that most of the older folks at least know, which is the one that Leslie documented at Addison Wesley in a book. And the number 209 wasn't intended to be there, but somehow it ended up in the book because somebody didn't. I mean, it was probably considered to be LaTeX 3 back then by him, but somebody didn't update it, and that was the version that they actually put into print. And then 1994 or 1993, depending on how you look at it, was LaTeX 2 Epsilon, which is the version that, well, essentially all of you are using if they are using LaTeX. So that is quite old. And then there's, of course, the solution to the problem for those people who attended the talk of Donald Knuth in 2010. And it was 10, or was it? No, it was 10. Unfortunately, it hasn't arrived yet, so we are more dealing with the period in green.
Nobody can pronounce it properly anyway.
Pronounce it correctly, please.
Ding, ding. Okay. Yeah, so let's talk a little bit about major disruptions that happened in that 40 years. And this is a biased thing, obviously. But for me, there are sort of 4 major bits. The first one is the birth of TeX, which changed quite a lot for many people. I mean, what they could do in terms of typesetting as authors using computers before and after. And in the beginning, there was the plain text format, and very soon after, the AMS, I think, asked Michael Spivak to actually implement more impressive and well-done mass typesetting facilities, and that what became AMS TeX. That was a start. And AMS TeX was something for articles, short papers, so what mathematicians typically do in many cases. And plain TeX was something where you actually have to build your own style and actually work out how your documents look. I mean, the plain TeX format as such is not very usable for many tasks out of the box. You actually have to put some extra effort in there. So the second sort of thing was then that with more users, there was a need for more structural needs. And that actually was the birth of LaTeX. Leslie thought, I need more than what plain TeX requires, and he came up importing to a large extent the ideas of scribe and implementing them for TeX and bothering Don to put some more stuff into the TeX engine. So some of the stuff that you these days finds in the TeX book as Appendix D dirty tricks are all stuff that Leslie sort of said, I need something like this, how do I do it? And then Don came up with new ideas. So those were the structural needs that changed the world in that space. And then, as a next step, which also again was a disruption, where the user needs were growing. More users, more wishes what you want to do with it. And so you see stuff like 7-bit fonts were the first go, and people were not very happy, especially in Europe, with the guys having fancy accents on letters in their names and stuff like that. Initially, there was, you can use any font you like as long as it's called Computer Modern and looks like this. That was also something users started to sort of feel kind of bad about it. They wanted more. Font industry actually came up at that time also with new font formats, and that was something that driving it. Another area is the graphics, colors. That was not actually implemented in TeX, so there were ad hoc solutions to solving that problem. Those problems were only available for a specific site, for a specific printer, and there was no interface that actually allowed sort of nice, and this is the idea of TeX, cross-site collaboration, because what worked on my machine with my printer didn't work on somebody else's machine with their printer, so the solutions were all ad hoc. And I apologize, this is just a little bit too small. Oh, what happened now? This is not very stable. Here we are. There's the problem. I have to read, and my eyes getting worse these days. I can't read this, I can't read that. Yeah, complex mathematics. I said we have the AMS stuff, but that was its own format, and in LaTeX it was just equation array. And as most people know, this is the worst kind of implementation and typographically solution that doesn't really do the right thing for most mathematics. So the result of those were we got TeX 3, we got Don sort of pressured into remembering his Nordic ancestors. We had the flexible fonts usage and the graphics that was resolved in some sense with LaTeX 2 Epsilon, where we abstracted the graphics into an interface which is driver independent and have all these driver files that Joseph was talking about, but this was outside of the user visibility, if you like. So from that moment on, you could, to some extent, I mean, of course, if you have a picture in a format that is not understood by your printing devices, then you still had a problem of sending it around. But on the whole, the situation meant that the documents became compatible between sites again. the complex mathematics and the internationalization needs were also addressed at that point. I mean, we imported all of the AMS tech by building a solution that these days is called AMS Math, which is sort of offering that kind of functionality on the LaTeX level. And multilingual stuff, at least for Western world type languages, was then provided with in form of Babel and so on. Okay, so that was sort of the big part in the middle. And then, in some sense, we had a bunch of external influences. There are more, but I think the most important one, or some of the important one for the tech world is, on one hand, that at some point the PDF format became sort of a very important format. I mean, we all started off with just DVI being wonderful because it's device independent. Okay, we know that in the end, in some sense, PDF took over, and one of the important bits here was that there was engine support for it. I mean, you could produce PDF before by going through the DVI PS, PostScript, and then PDF route, but then suddenly we had an engine that would do that internally. And the other big external influence, in some sense, that was brought from the outside to the tech world was the event of Unicode becoming more and more sort of a standard. We had first engines that were trying to address that, like Omega, and then more engines that were picking this up, like CTEC and then LaTeX. It became more and more popular, obviously because for people who actually have a need to work with such languages that have more characters than just the ASCII ones, or in something like German or French, a few characters that have accents. There, Unicode is really essential, or the ability to address fonts having those glyphs, etc. So that was something that over time more and more people are interested in. I mean, right now we still have the situation that the predominant and default tech engine is PDF tech, but the user base of people who are using the other engines, the Unicode-based engines, is becoming bigger and bigger, and I foresee, depending on how things are going, it's also a question of support and stability in terms of being the same, that by a couple of years from now, we will eventually see that one of the Unicode engines is going to be the one that is sort of becoming the default standard, and most likely that will be, I guess, LaTeX. But we are not there yet. Anyway, if you see this line drawn here, a few years back, the LaTeX team officially sort of announced or said that we are going to support LaTeX not just on PDF tech, but also on the Unicode-based engines. I mean, LaTeX was used on the other engines by people sort of hacking into the LaTeX kernel and adding some extras when the format was produced. But it was never official, and it was breaking some things. And by taking that step, by taking that back into sort of the official distribution, we were trying to sort of making sure that those kind of things work smoothly. So this was about 2015, so 3 years ago. And the other thing that happened with Unicode is that when I started with computers, most of them were 7-bit, some of them were AppSatic, for those people who know what that means. And then came the 8-bit computers, basically with all these code pages, with the national code pages, where you were sending files around in the world, and the email system wouldn't understand that you are actually in a different country, and therefore everything got messed up, and your emails have phrases instead of accented characters if they come up on the other side of the ocean or anywhere. So yeah, this all changed, and more the Unicode as an operating system standard is becoming the default. So these days you have to work on most machines that people use. You have to work rather hard to save a file in an encoding which is not UTF-8. So acknowledging that fact, this year the team decided that we make one change in the LaTeX distribution, which is that we assume by default that files are in UTF-8. So this is sort of kind of where the big areas are that I think. So how did we over those decades handle those disruptions, and what does this mean to compatibility of files and documents and so? So let me start with the early years, early LaTeX 209. The starting point was, well, it was a very small user base. Few people basically around Leslie and his team were using what Leslie was doing. He was doing it for himself in some sense, the same way TeX started out. It was a small code base because Leslie only implemented sort of bare bone HTML kind of tags. You had lists, you have headings, and you have 3, 4, 5 other things, 3 math environments, and that's it. And consistency was not a problem. It was done by one scientist who had quite a very good feeling for what kind of interfaces to provide. He was basing that on Scribe, which was a huge step forward when Scribe was developed compared to what else was there beforehand. And all the users were basically computer nerds. So installing and all this kind of stuff, there was not a question initially. And the goals for at that point was, well, basically provide structure that plain text wasn't providing. That's the main goal of LaTeX at that point. And the second goal was just to get going. There was nothing before there. And the compatibility approach, therefore, was, well, you had just a single developer, so there was nothing beforehand. So there wasn't much question of being compatible with something from before. It was just providing new stuff. So that was easy at this point. And then it became popular, and was becoming popular. It got new users, and then the problem starts. You get a larger user base. Those users have new needs. Those needs are not necessarily addressed by the original implementer. Therefore, you get new developers that write packages, and LaTeX was always conceptually open in the sense that you could add to it by providing packages. It was called styles back then, but same idea. You add code and it works, or it doesn't, depending. The result is you have different people having new ideas for new stuff. These ideas are not necessarily synchronized, and you end up with inconsistent interfaces, different ideas, possibly overlapping ideas, and so on and so forth. So the system got bigger, it got more powerful, but it also got less usable. And with the event of the need for new fonts and all this kind of stuff, it ended up not being one of the main goals that TeX really had, of being the same all over the place. You can rely on exchanging your documents, because LaTeX just around the 90s or 92, 91, you had about 4 or 5 different LaTeX. LaTeX with AMS tag included as in the kernel, which was called the AMS LaTeX stuff. You had different font mechanisms. I wrote the NFSS back then, and so there was LaTeX with NFSS without the font selection, with the old first version of the font selection in the format, with the second version of the font selection format. None of this would work with the other. So if you've written a document in one of those formats, you couldn't give it to somebody who had, for some reason, something else. So that became a bigger and bigger problem. And of course, Leslie is a scientist, and he had done this kind of stuff not because he wanted to do typesetting as a hobby or as a main occupation, but rather to do research. And he got less and less interested in actually doing anything about bug fixing or whatever was necessary with this new user base asking for new stuff. So that was a big problem. And so essentially Chris and I and David, we got basically dumped that on our laps when we asked Leslie too many questions and said, hey, why don't you do it? And that's where we ended up with. And yeah, as a result, we then produced LaTeX 2 Epsilon and to solve all the problems that we could think of being solvable and so on and so forth. So the idea was to have unification of these incompatible versions and approaches, providing missing interfaces like the graphic stuff, the color stuff, and those kind of things, providing additional functionality, but in the way that, again, everybody has the same, has a good way. So we introduced the package mechanisms and those kind of stuff. Compatibility. Well, back then we made a big jump. And we did this by basically saying there are old documents and new documents. And the old documents start with document style. That's the way original LaTeX was. And the new documents start with document class. And that was the first thing that was in a document. So you could tell from the very beginning, you are running an old document or a new document. And for the old document, there was a compatibility mechanism built into the LaTeX format to process those old documents and some of the features or functionality that was changed. But at the same time, we deliberately turned off all the new features. So basically, if you would write document style in a new document, you would not get any of the goodies, in quotes, of what LaTeX 2 Epsilon was offering you. Because we didn't want to have these kind of mixed and match where people sort of, again, have incompatible stuff being used in parallel for a long time. So the idea was the compatibility was really process old documents as best as you can, but not mixing that by writing new documents in the old style. So that was the approach, and in fact it worked quite well, I would say. Okay, so that was 1994, and then, okay, initially there were some problems, a little bit of maintenance releases and stuff like this. So the starting point at that time was to bring back this consistent basis, and that was initially quite good. We had many standard packages, but we didn't have so much else at that time. And the goals for compatibility was, as I said, to be able to process the old documents. That was the compatibility to the time before, but also because of the standardization and having everybody sort of, again, using the same kind of mechanisms, ensuring that for many years you have a way forward which actually, again, provides stability. And the approach for compatibility then into the future was this one. After doing this big step, we essentially froze the kernel. So the LaTeX core was more or less fixed. And yes, the very first releases, there was still sort of fixing the stuff that we overlooked and so on and so forth. But basically, the kernel didn't change after this consolidation part anymore in noticeable ways. And the idea that we had back then was that we provide a little package which is called fix2 epsilon, and any sort of bigger changes that we think necessary and that are potentially sort of incompatible to old situations would go into this package, and people could load it or not. So if they want to have a certain fix that would break old documents, but they wanted to have it in a new document, then they could use that. Then the other assumption that was made is that packages, I don't know, whatever, long table, array, you name it, all the packages that have been done by either members of the LaTeX team or by the many other developers, they were actually adding functionality. So they were not a problem in terms of compatibility. Looking into the future, which of course was very much wrong, but that was the idea. So why did it fail? I mean, first of all, the idea of fix2 epsilon, this package didn't work. Why doesn't it work? Well, simply because this is a package which was a moving target. Whenever we added a fix, for example, there was a problem that floats could get out of order. This could only be corrected by changing the complete float algorithm internally. Because that was such a big change that would potentially break packages or break documents, we didn't put that into the kernel. We said, okay, there are some cases where the float algorithm is wrong, but we put this into fix2 epsilon. Okay. Now, depending on the date of fix2 epsilon, if you have an older document, a newer document, you had this kind of big change inside this package or you don't. So documents not assuming that fix, but using fix2 epsilon, you run them 3 years from now, it suddenly has the fix in and the document is no longer working the way you thought it would work. So this document was, and this package was quite a problem in terms of not being changing over time. So that was precisely not clear what you get if you load this. Secondly, some package or classes actually loaded this package all the time because it said this is the fixes to the kernel. But then that means that those classes were also not stable in the sense of if you run the document today and you run it in a year, it might have some changes in that do change your document. And thirdly, and this is in some sense the most important one, even those important fixes, like the one for the float handling, it was only ever seen or used by very few users. So the majority would not see that package or use that package. So they would always stay on the old buggy version. So we wouldn't get any sort of corrections long-term in. And any package that does hooking into some of the interfaces of the kernel would now start to have different code depending on whether it's the pure kernel, the unchanged one, or it's the one that has the bug fix, because it loads this package. So you got all in all these kind of compatibility issues. And for the, this is what it says here. And for the package development, we have, you can't read this, sorry, this beamer is not really nice to my slides. Yeah, this is just saying that fix2e wasn't really used very much. But the package development was having a similar problem. First of all, the packages many packages were not just providing new functionality, they were providing sometimes new functionalities, sometimes layout changes, and they were from time to time providing incompatible extensions. In other words, they were changing the stuff that they'd done before in a way that the old documents using this package would no longer work. In other words, something similar to what I was talking about in the doc. An example is, for example, the famous caption package, or I don't know, famous, most people will know it. It was originally called caption, and then the author thought, oh, I didn't get it quite right. And he thought, I can't really have the old users in the rain, so I call the next package caption 2. And then he thought a while later, oh, this is not good either, so I call it caption 3. And then people said, oh, we don't like caption 2 and caption 3 and so on. And he didn't like that either, so he renamed caption 3 after one or more little changes to caption. So at that point, old documents using the original caption, of course, wouldn't work anymore. Besides, as we all know, people have the tendency to take their preamble, copy it from one document to the next. So depending on when you enter the LaTeX world, you would have the word caption there in one of the loading use packages. If you were a little bit later, you may have had caption 2, so you would always stay on caption 2 even through the caption 3, or the renewed caption package would have a much better interface, much better functionality. So all these mechanisms were not quite working either. So you can't read this, but this is essentially what I just said. Yeah. So we got somewhat stuck. On one hand, we had the kernel being frozen for nearly 20 years, largely, and the package mechanism were making, again, incompatible stuff. The interfaces, there were starting to become more and more dependency between different packages that were not resolved very nicely. And, well, we all learned, well, most of us at least, I guess, you touch something in the kernel, the very, very clearly simple stuff that nobody could have bothered with, you fix something here and it breaks over there. It's incredible what kind of things happen there. And so essentially everybody got the feeling that touch anything and you will break a lot of other stuff. So the question is what to do then. This says, so what now? Down there on the right. Yeah, so by the end of the day, we got the, we thought that there is a need to do something about this. And the first step that we did was in 2015. We introduced a rollback mechanism for the kernel so that we can actually make changes to the kernel, get fixes in. But if you have an old document or you have the need to have a kernel version from a certain time, then there was a way to get to this. So this was in 2015, and in 2018, in other words, this year, we extended that to cover the concept of classes and packages. How does this work? We introduced a package called LaTeX release, and if you say use package or require package, if you want to put it at the very top of your document, require package LaTeX release, you can give it a date, and then it tries to roll the kernel back to the state it has on that date. In fact, you can also roll it forward. So in other words, if you're stuck because you're using a university installation with a certain installation, say from last year, because this is what your computer service is providing, but you have a document which is actually requiring the kernel from this year, the only thing you needed was the current release of this LaTeX release package from the other end. So once you have that on your local installation or your local directory, you could even roll forward to the current version. This is too big. So this is you have require package, then you put the date, and this is what it does. Okay. Internally, sorry for the. Can you read this? Internally, this looks rather horrible. In the kernel, we have when we do changes, we say when it gets included in a certain release, we give that a label. Then comes all the code for this release. And then we have some more for the version of the certain part in older releases. That is doable for us because on the whole the kernel is fairly stable, and there are some advantages why we did it this way, but it is not something that we would want to expose to every package writer or something. This is fine for the way the kernel works, but in theory you could use that in a package, the same kind of mechanism, but it wasn't considered to be really something that people would pick up for the package level. So we understand that there was a need for something else. So what are we doing for packages when we introduce? Is this getting bigger? So, okay. Yeah, as I said, we introduce a general rollback for use in documents, and this goes like this. It is actually using the same mechanism. So with the 2018 kernel, if you put this require package with a date of the LaTeX release at the top of your file and a certain date, then it will roll back the kernel to that date, and it will roll back all the packages that using rollback. So far not many are using it, but packages that are aware of different release stage will roll back to this date as well. So you can also do it on an individual package. I don't know how many people know that the use package actually has two optional arguments. One up here for the options to the package, and then there was one after the package name, or there is one after the package name. You can put a date in there to say, I need at least the version from that date. That was the original idea. So you say, because you know that, I don't know, the long table package has a special feature that was just introduced last year. So you put into your source, I need a long table from at least that date, because if somebody has an older version, that feature wouldn't be there. And so this way you can get a, basically never used. I don't think users have used this. So what we did was, well, some people do. What we did was, we hijack that argument. It's still working like before, but if you put an equal sign, this is just saying about this. So if we hijack that argument, if you put an equal sign before the date, then it is no longer the minimal date, but it is I want to have that date as far as possible. I mean, basically what the rollback mechanism does, it goes back to that date or the next earlier one if there's no release on that date. So this is the idea. So basically, when you have just a LaTeX release there, everything rolls back as far as possible to that date. If you want to roll back a certain package only for some reason because it has a certain feature or something at that time that you want to make sure that you get exactly this, that is possible using this optional argument. The same is possible for classes because they have this min date argument as well.
How does the require package in the last slide work? Because date and release.
Sorry?
You only use the date and release. What does the package name?
The package name is LaTeX release. Sorry, this is the disadvantage of using software that is not so sophisticated in this space. This is not italic, then it would be clearer. This is an abstract date, therefore the angle bracket. This is the real package name. So you say require package 2018 something, and the package name is LaTeX release. Sorry. Here, this is any package, therefore the angle brackets. Okay? Yeah, so how does this work for package authors? Well, basically you have a little declaration area on top of your package where you declare your different releases. And you declare a release, you can give it a name, you don't have to, which is sometimes useful if you want your users. If, for example, if you have, again, a nice example might be long table, which is for a long period of time on this version 4, but there are a lot of ideas and wishes by users to come to a version 5, and this will be partly incompatible. This is probably just the way it is. And so David could put here declare release version 4 and this way provide an interface that users can say, give me long table version 4 as a named version rather than a day version, because there might be something where things are actual parallel. So you can have as many as you like of those. The only requirement is that the date, there is an actual date here, and the dates are ordered in terms of earlier dates to later dates. And the last line is the current release that just have a name and a date. Those here have external files as a third argument. So basically the code for that release is in some external file. Which means for a package author, if I want to use this feature and I have an old release, I just have to stick the code of my current release into one file, give it a name, and add one of those lines. And that's it. So you can basically just take the current.sty file, give it a sensible name, which is typical your package name, maybe with hyphen date, some date now attached to it, and stick that into your distribution. And below this declare current line, the rest is then just a normal package code as before. So that's the way the interface works, and it is clear, I think, that for most people that have developed their own stuff, this is not meant to be used for each and every little single change. It is meant for changes that are likely to break either compatibility completely, then it will be a really good idea to do this, but also if they are producing very strongly formatting changes, which is also a form of compatibility change. But certainly not for having each and every one-line change in the code or internal change being done by a release. Oops, sorry, where am I? I was the wrong. Yeah, you can do more granular stuff in those extra external files. There is something where you can have in a single file then branches that allow you to execute different code depending on what date is being requested. But this is really only for if people want to sort of compress this. The alternative is to have two different files. Okay, so this is sort of the way it is working. For us, it means, in some sense, a very big step forward because we can fix important things in the kernel without compromising the compatibility. We also have now on the package level a way to provide every package author with the same kind of interface for handling different versions and incompatible versions. So instead of caption 1, 2, 3 back caption, or other packages actually have options where they say version equals and then they have something. There's now a sort of standard interface that could be used by any package author from now on. You can even retrospectively add older versions that are currently more or less forgotten or meaning that the old documents do not longer work. So for example, in the caption case, they could be all put into one file, into one package now. So, yeah, this is basically what I was just saying. And the other thing which is also quite, I think, interesting is if you have finished an important document, like a paper, you could end and say require whatever date today is, provided you have a recent LaTeX distribution and not one which is ages old. You could put this on the top of your file, and then basically whenever this paper is run in the future, it will try to get everything back to that stage. So it actually tells basically what you expect in your document and will try to obey that. The line below says, don't trust it too much. I mean, if you write a book, you should make your whole environment and store it away if you want to do that in 20 years. It's the only advice that I can give here. But okay, so, and now. I strongly believe that there is a need to actively maintain, improve, and develop further depending on what kind of new needs are coming. So this for us is I think, a very important step in my opinion. Yeah, a few words here. It is not easy. People like to stay with whatever they have. And any change that is not just obvious for them, or maybe actually not necessary for them, that gives you a lot opposition. And so just to finish off here with some sort of history stuff, when we did 2 Epsilon, we nearly got killed because our friends in the US, largely, they said, why do anybody want these extra fonts? They just take place on my machine. And this was a very, very hard sentiment. Most people, or a lot of people were very vocal back then that this is doubling the size of the distribution because we suddenly had 8-bit fonts. instead of 7-bit fonts. And there was a lot of opposition back then. And when we introduced the change to have Unicode or UTF-8 being the default input coding, the situation was quite similar. You can't read this, but essentially it says we got an email, and the statement was, you are going to break everything. Everybody will be unhappy. Everybody will, yeah. And the fact is, instead of the typical 3 patch releases we must push out after a release because we overlooked something despite all the regression testing and what we do, or some arcane sort of combination that we can't test. This time we had 5, in short. There were some things which we just didn't get right. But honestly, on the whole, most people didn't notice. The big advantage now is you don't have to load input enc. If you have a UTF-8 file, you can just use accented characters, what have you, and it will work out of the box. If you have a file which is in a different encoding, like Latin 1 or whatever we had in the past, old files, it should have said all the time input enc bracket use package bracket open Latin 1 input enc. And all the files that were doing this, they work like before. So the only change really is that you're now having not to worry about Unicode if that is sort of the default situation. Anyway, it didn't break the world. And I hope that in the future we will be able to gradually sort of improve things by slightly breaking something and then fixing it immediately in patch 2 and 3 if necessary, but on the whole making it better. So, and I think especially this topic about accessibility, text, PDF, and so on, will pose the same kind of problems. We will have to make some changes where not all of them may be 100% compatible. So having rollback and back and forth and those kind of stuff will be a very good sort of basis for this. Secondly, we will make mistakes that we have to correct. But again, as I said, I don't think we will break the world here. And with that, I like to finish.
Questions?
Required date, will it be used by use packages also? So the packages themselves can call this number.
You mean if you have use package, then you have your optional argument here, whatever, final. And then you have your package name. And yes, you can put on a single line here a required date. Normally that would mean this package has to have this date as a minimum. If you say equal 2016 1, sorry, of course, then going like here. Then this means this should be an equal sign. Try to give me that version from that date.
No, my question was, will the package developer will have access to the date of
nesting plan? You know, we had those issues with where someone's got it in within another package.
The LaTeX release date is available. The individual package date. So if this package is loading other packages inside the package, and you're asking for a certain version.
No, I'm saying that, let's say versions or something.
Yeah.
So will I have access to that number?
You have access to the rollback number that is requested for the whole document. Yes, that is available as a internal command string. So you have that data available. That's in the documentation.
So if we know, okay, this package I need minimum version is this, or whatever, so I can ensure that, right? So see, some packages only work for this version, right? Because my package probably expect you to have certain version.
But you could write such conditions.
Yeah, the conditionals are possible. Yes.
So that way it's very interesting because then you make sure that works well.
Yeah. But that does work. I mean, so those dates or the date from the overall request are available. Yes. Tom.
Okay, I just want to make sure when you speak about require package and use package, you also speak about load class and document class?
Yes.
Okay, thanks.
As I said, all those loading stuff have this minimal date interface, even though most people don't even know that it exists.
Thank you very much.
Yes. Was there a question?
Any
Was-
more questions?
Was there a question? No, behind you. Okay, fine. Good.
We have a little change in the schedule right now. I'm gonna change over with Joaquin Hines, and he needs a little bit more time for his talk. So if you plan to skip mine, you can have a very relaxed and late lunch.